Now it's time for Lesson 11D. In the next preview assignment in the next class, you will need to be able to write equations for scenarios that involve directly proportional variables and jointly proportional variables. So let's start with direct proportionality. Two variables are called directly proportional if. You'll remember that glossary or those flashcards or whatever it is you've got collecting all of these words on. Here are some more words. Directly proportional is going to be this. Two variables, where one is a constant multiplier of the other. Put it in your own words, put these words down, put down some examples. In particular, when one variable changes, the other changes in proportion to the first. Proportionality involves multiplicative change, and it's based on the constant of proportionality. So we have lots of words going on here. The constant of proportionality, where one variable either increases or decreases at a constant rate as the other variable is increasing. In other words, we're going to be looking at if one variable is going up on the x, the other variable could be coming down. Or as one variable is going up on the x, the other variable could also be going up. In Worksheet 80, when you wrote equations for flat taxes, there was an example of direct proportionality. The tax rate was the constant of proportionality. So looking at question 1, as long as you have already hit pause and you've already attempted question 1, then keep listening. If not, hit pause and we'll see you in a minute. Sales tax is another example of direct proportionality. If sales tax is 8%, write a formula for calculating the total sales tax on an item to be purchased. What is the constant of proportionality for your equation? And let's try to use some variables that are going to be indicative, give us an idea of what we're talking about. Like, maybe we could call this T for the amount of tax that we're going to pay. And the amount that we're going to pay is 8% or 8/100ths times, and it was talking about an item to be purchased, the cost of the item. This is a way to write the equation, and then once we do, what is the constant of proportionality? The constant of proportionality is our 8/100ths. Working on some more of these, and remember, hit pause, go work on them yourself, and then come back and let's work on them together. Question number 2, on a recent trip, Joyce noticed that she had traveled an average of 24 miles for every gallon of gasoline she uses or used. The number of miles traveled is directly proportional to the gallons of gasoline used. So the number of miles is directly proportional to the gallons of gasoline used. 24 miles to every gallon, and then the number of gallons of gasoline used. Write a formula to determine the number of miles driven. So the number of miles driven is going to be 24 times all the gallons of gas used, and we're going to come out with our number of miles driven. Here's our equation, the constant of proportionality. Never abbreviated it like COP, but constant of proportionality is going to be, or is, 24. Keep going, looking at question 3. Some insurance companies offer savings on car insurance because of safe driving. Let delta I represent the change in the insurance cost. Safe drivers receive a 2% discount on their total I every billing cycle. The change in the insurance cost is the change in the insurance cost. The change in the insurance cost is directly proportional to the cost of the insurance. The change is directly proportional. So it's going to be something times the cost of our insurance 2%, we will write it as a decimal, but with it being a discount, we get to write it as taking away or a negative discount, which is going to be a negative 2/100 times the cost of the insurance. The constant of proportionality is our negative 0.02. And I don't like the way I wrote that. I like it with a leading zero. Both are beautiful, but I like that better. And then a little bit to read that says, often the constant of proportionality for a specific scenario is not stated explicitly. Everything we've looked at so far, it was in our parentheses, our paragraph, sorry, and we could pull it out, we could manipulate an equation, create it, and come up with our constant of proportionality. So another skill you're going to need is to know how to calculate it using information that is given in the problem, and it's several steps. This could be included in your glossary or flashcards because the several step process needs to be set apart that we are finding the constant of proportionality using our given information, and then once we know what it is, we can go back and use our new constant to solve for new information. So make sure you hit pause, make sure you work through these steps by yourself. And the one that you're looking at on my screen is a little blurry, so make sure you have your printout and you're writing on it, and that's what you'll upload for this week's assignments. Use the following step to find the constant of proportionality, and then use it to calculate the requested information. Suppose z is directly proportional to x, and that z is 27 when x is 54. Slowly, methodically, part A says write a formula for z in terms of x and use k as the constant of proportionality. So z is directly proportional to x. That means we have a constant of proportionality. Moving on to B. And remember, these are going to be our multiple step process when we don't know the constant of proportionality to go find it and then be able to use it in subsequent problems. So the first thing we did, we wrote our formula, a very generic formula. Then we're going to substitute what we were given for x and for z. Notice right here, we were given a z and given an x. The only variable remaining should be k, the constant of proportionality. So they told us that z is 27. We're looking for k, and z is 27 when x is 54. I started to get to the next question because all they're asking right here is to substitute. We did. Part next, C says go ahead and solve for the constant of proportionality. So I'm going to start right here, and to get k alone, I need to divide both sides by 54, and then it's k times 1, or just k, equals 27 divided by 54. It's kind of looking like we're going to have a half here, but I'll go ahead and pause and do 27 divided by 54, and I end up with a half, or the decimal version, which is 5/10. Then our multi-step, and by the way, it's always a good thing to stop this video and go back and pause, meditate, think on these steps where we wrote a formula, we plugged in our given, we solved for the constant of proportionality, and now we're going to put it all together. We're going to rewrite the equation from part A. Part A was z equals kx, using the value that we found for k right here. So our new equation will be z equals 5/10 times x. And I think I've got e. Oh, I have e. Look at there. And so now we're going to let me get this back where it was. We're going to use the formula from part D, this one that we just found here. And now we're going to determine the value of z when x is 458. Now we can do anything. We now know our constant of proportionality. So we're taking this formula. Our z is worth 5/10 times x. Well, now we know 5/10 times our x of 458. So z is going to be worth, I'm going to plug in 0.5 times 458, and our z is going to be worth 229. Now that we know our constant of proportionality, and we're able to plug in anything that they give to us, and now we have a process, but let's look at it just a little differently in the next question. This is a great time for you to hit pause and go ahead and look at question 5 and beyond, and then come back and we'll walk through 5 together. Just before 5, it says sometimes you're going to encounter situations where one variable is proportional to a power of another variable. And we're just going to do the same process to determine the constant of proportionality, just like what we did in question 4. But the initial formula is going to include at least one variable with an exponent. It says suppose W is directly proportional to the square of x. Write a formula for W in terms of x. W is directly proportional to the square of x, and use K for your constant of proportionality. When we get to part B, it says if we know that W is 18 when x is 3. Let me get me some more space to write. Part B says if W is 18 when x is 3, determine the constant of proportionality. So what we did just on our last question, we wrote the equation first, then we took our given and plugged it into our equation. So instead of W, I'm going to plug in the given of 18. K, I don't know, and I'm going to take x of 3 and plug it in. Remember, or go back and review, that what we did last time is we then solved for K. 3 squared is 9, so I'll go ahead and divide by 9. That becomes K times 1, and 18 divided by 9 is 2. So our constant of proportionality is 2. Then question part C says rewrite the equation from part A using the K that you found in your part B. So now that we know the constant of proportionality is 2, we're going to go back and rewrite this, that W, which is directly proportional to the square of x, has a constant of proportionality of 2. We just looked at direct proportionality. Now we're moving on to another word or set of words, joint proportionality. Make sure you're putting in this in your list of vocabulary. 3 or more variables are called jointly proportional if one of them is directly proportional with each of the other variables when taken one at a time. For example, if z varies jointly with respect to x and y, the proportionality equation will be in the form that z varies directly to x and y, where k is a constant of proportionality. Looking at part 6, remember that you have already paused, and if not, you're going to pause now, and then go ahead and work on question 6, and then come back and work together. Work with me together. So part 6 says, suppose that P varies jointly with Q and the square of R. P varies jointly with Q and the square of R. We have to include our constant of proportionality. Part A says write a formula. We did it. Part B says we're going to have some given items, and then we can determine the constant of proportionality. So P has a value of 48 when Q is -3 and R is 2. Determine the constant of proportionality. I'll go ahead and write that 48 is going to be K times, well, we've got 4 times a -3, so that's going to put us at K times a -12. Move this all over here, and the 48 equals K times our -12. So let's divide both sides by -12. This becomes 1, and our k is worth a -4. Continuing on, rewrite the equation we had in part A. This time, use the constant of proportionality that we found in B. So our P, which is directly proportional to Q and the square of R, we now know has a constant of proportionality of -4. Use this formula we just found, to determine the value of P when we know that Q is -2 and R is 2. I'm going to go ahead and just jump straight to the formula and not rewrite it, and just say that P is worth -4 times when the Q is -2 and when the R is 2, but in this case it is squared. So P is going to be worth, I'm going to need to do exponents and some multiplication, and a lot of it can happen at the same time, like my -4 and my -2 will be 8. My 2 times 2 is 4. And either way we go here, we're getting that the P is going to have a value of 32. Part E asks us to compare our answer from Part D. Here's Part D. Compare this answer to the given information in Part B. So right here we have some given information in Part B. And it says, let us look at the information. Sorry, my eyes are jumping around on the paper I'm looking at. We're going to compare what we got in Part D. Right here's what we got in Part D. And they want us to compare it to what we were given in Part B. Does the P increase or decrease if Q increases? In other words, our R is held constant. And if you look right here, our R is 2. And if you look right here, our R is 2. And that's something we'll be doing in class, is we'll hold a variable constant. So R is not changing. Let's look at what is changing and talk about how it impacts the other variable. So if we hold R constant, let me read it one more time. Does P increase or decrease if Q increases? So let's look at Q. Q went from -3 to -2. So Q went up 1 point or one number. Q went up. So as Q goes up, what is happening to P? P was 48 here, P is 32 here. So the answer to Part E, P decreases when Q increases. And this is going to be because of the negative constant proportionality. Right here's the culprit, -4. Part 7, the formula for volume. It's used to calculate volume of a cylinder, and it's an example of joint proportionality. Part A, what are the variables that are in this formula? Well, V for volume, R, which is going to be a radius, and H for the height. What is the constant of proportionality? Well, pi. Pi is 3.14 and beyond. Part C, will the volume increase or decrease if R and H both increase? Justify your answer by plugging in a few values for R and H to show the effect on V. So let's keep this simple and even keep it organized. Let's get us a table going. We're going to need some variables. Wow, the drawing is really bad right now. So like R, H, and V. Wow. And looking at these variables, let's play around with, I don't know, how many do we need to get a good pattern going? And so playing around with these, what if you let the radius be 1 and let the height be 1? Let's see what volume we're going to get. So volume is pi times 1 squared times 1 and that's going to be 3.14 times 1 times 1 times 1. Well, it's kind of about-ish 3.14. Let's let just the R go up and leave the H alone. If that's the case, the volume is going to be about 3.14 times R squared times the H. So we've got 3.14 times 4 times 1, and grabbing a calculator, 3.14, oh goodness, 3.14, nope, 3.1, I'll get it in just a second. 3.14 times 4 is about 12 and 56/100ths. So far as something increases, so does the volume. It goes up. But let's keep playing. Maybe go back to 1 on this one and use this one as a 2. Let the height go up a little. 3.14 times R squared times the height. So I've got 3.14, that's a 1, that's a 2. And so that's about-ish 6.28. Well, it's up. Well, let's do one more. So let's let them both be 2. So our volume is going to be 3.14 times 2 squared times 2. So we've got 3.14 times 4 times 2, or 3.14 times 8. Wish me luck on the calculator here. 3.14 times 8, and we're getting about-ish 25 and 12/100ths. And so as our R and H are increasing, we can see that our volume is going to also increase. Whereas we were at 1 and 1, when we increased the radius, we went up. When we increased the height from the 314, we went up. When we increased both, they really went up. So it's going to increase. The last thing that we're looking at in this lesson is that we're going to generate 2 graphs on a single coordinate plane in a spreadsheet. And you're going to need to do this in the practice assignment, where you're going to show 2 graphs on the same coordinate plane. You do have an 11D worksheet, and it's in D2L under our content and then under Excel spreadsheets. The point that they're trying to make here is that column A has the values of X. That's important. But column B has nonsense values, and we want to avoid them. They're going to hurt our graph. Column C has the values of Y for Y equal 3x minus 2, and column D has the values of Z, where Z is 2x plus 1. If B was not there, we could just highlight and go up and do insert, depending on which program we're using, and get the graph going. But since we have to skip over, we're going to highlight the data, whether for the graph or any other purpose, and we're either going to use the control key or a command key. And so what they're asking us to do on part 8 is, in the spreadsheet, generate a graph of both the Y and the Z as functions of X on the same coordinate plane. So I have already downloaded the file, the Excel file that we are looking for, and I'm going to do what they're asking us to do. I'm going to go ahead and highlight the first column and hold down the control key, and then highlight, well, I could probably highlight them both together, the Y and the Z. And like we've been doing a bunch lately, I'm going to go to Insert, then to my charts, and let's go ahead and graph we can get the scatter, we can get a line. Let's go ahead and do the line. And then when we click OK, we can do chart titles and labels and things along those lines. But the big task here was to be able to skip over the nonsense column and then still create this graph that has Y and Z both as functions of X on the same coordinate plane. This finishes lesson D. You need to look at your syllabus to see if you have more lessons that are due for this week's deadlines, and make sure you do those and then upload those before Friday night's deadline. And if not, you're done with this week, then go on and do history, English, or some other assignment. But I'll see you soon on another lesson. Hang in there.